Good afternoon. At this particular point, we want to try to manufacture this particular part. It happens to be a gear blank. And we'll look it over first to see what operations we may or may not need to use. I can see that we need a close tolerance bore. We have close tolerance diameters. By the way, they're unilateral, which also indicates it's a gear blank because we want down, not larger. 2.9 minus 5, 2.4 minus 5. The groove is 1950. Okay, so we see these dimensions. We know what we're going to make. Now we're going to prepare the machine to get started. Okay, I'm going to put my print here. The methods on how I want to do it are over here, which are pretty good to follow these. We can do it like a checklist. And we have our print. Okay, by the looks of it, we have our blank. This is our gear blank for this particular project. Looks nice. And we can check it. And it's showing us to be 3 inches. Fine. Okay. We're going to install the part in the chuck. Again, righty-tighty. Next one, righty-tighty. Righty-tighty. They give you 3 tightening positions. Always use all 3. Now, we can remove our safety plate. We're going to come over and we're going to position our chuck. We're going to position our compound. Our compound needs to be properly set, and I recommend highly that the front of the compound be parallel to the face of the chuck, which means the compound will be parallel to the bed. And that means we set it on 0 here. And leave it. And over here, tighten this guy up. Like so. I highly recommend that the front of the compound and the bottom are about even. And it's important because you don't want to hit these jaws. And I usually get it close to even. I set the compound to 0 for later use. So I'm going to put it on 0 right here, and that's good for now. The next thing, as we work up to position everything, we're going to loosen our tool. Well, let's take our tool holder off. Now we have our tool post, which I need to position. Okay, I think we went through cleaning this once before. We can do a quick cleaning here just to make sure things are solid. And clean this off, clean this off, and we're back in business. On. Okay, now, proper machining would be 1 dovetail in and 1 away. In our case, we're going to be using the tail torque. So I think what I would like to do, we have to use this dovetail for left-handed tool, so I'm going to leave it the way it is. So tighten her down. By the way, I like to keep all my tools down, work tools, machine tools, down, and all measuring tools, prints, all measuring tools and prints, scales, pencil, Sharpie, maybe even this brush could go up or down either way, and your calipers and your micrometer, the tools that you need, measuring tools up. It definitely gets very, very bad when you have everything mixed up, tools and stuff start to fall off the machine. The little you have up there is just enough, and it should be just fine. Now, we also keep our cutting oil on the machine, or there, or down. I like to leave it there, it's not in my way. And we're pretty much ready to go. Now, according to the print, we want to face it a little bit. We want to center drill it, face it. The end result is center drill, drill, bore, and ream. And also make a nice face here for a banking surface for the gear to be. It needs a perpendicular bore to the face. This must be done together at one time. And I'm going to demonstrate that for you. Okay. Now, we take our tool holder and we put our tool holder up, and we have to make sure that we're on center line. And let me have a wrench to hold it. I like to keep the tool out about a finger. About a finger is good. And flush up against the back of the holder. And we can tighten 2 screws up. And we need to make sure that we're on center. And the way to do that is there's a couple of ways of doing it. We can machine center, or we can use a live center in the tailstock. My preference would be to machine center, which is pretty easy to do. You can get a machine center. And also, before we go, I like to still stay with the general process with aluminum. For us teaching, 3,000 speed rate, either facing or turning, is good enough to give you roughing and finishing. It's fine. Now, if you look at this part, you'll see that it's wobbling a lot in the front. So what I would like to do is just quickly kind of get it somewhat straight. Now I'm carefully coming in. I'm going to take some light cuts by hand, and I'm going to come towards center, and I'm going to try to find and make sure my tool is on center. This is what you call machining center. The tool is just slightly low. So all we need to do is take our adjustment, loosen it a little bit, loosen the holder. We want to come up, so this adjustment goes down a little bit. Tighten her back up, and tighten her up, and we should be good. We can spot check it. On the money, looks good. Now I'm going to try to just get this thing somewhat flat by hand. We can use automatic. It's going to take a little while, but you can. You're not looking for a finish. You just want to try to get it somewhat flat. So I'm going to just keep on going until I reach it. And I'm not going all the way to center. I'm leaving a little nub there. Let's just check. Looks to me like we could go just a little bit more. We have a little bit more to go. And we can lock the carriage with the carriage lock. And I can feel it. This is in good shape right now. So we're going to come into about there, and that's good. The next thing we're going to do, because we got this somewhat, let's remove our tool and bring our crossfeed back with the tool holder, the tool post holder, away from our center line. We're going to use the tailstock now. This is our tailstock, and this is a drill chuck, and I want to make sure that this is in tight. We take it out, come in, bring it in good and tight, loosen it up. We want to get our center drill in here and tighten it. 1, 2, 3. So I'm going to take the center drill, going to come in. Our carriage lock we can put down for now, not needed. And we bring our tailstock over, lock it, and turn on. I would make sure that everything clears. Give it a little spin. Looks good. Turn it on. Bring this in. And a little cutting oil on the tip. We're just going to give this a little start to the drill. Okay. So all we need is a little start. Turn on the machine off. Come back over. We're not going to need the center drill. I'm going to just remove it. And then I'm going to remove our drill chuck because we're not going to need this anymore on this episode. Okay, I'm going to put this down here. Work tool, remember tools down. Okay. Our operation called for center drill, boring bar, and a reamer. Okay. Okay, we have our tools that we need. We did the center drill. This is going to be a drill, 11/16, and a reamer that'll get us to that 7506. Want to be careful. And we have our boring bar. Now, according to the print, our methods, they're saying we did the center drill. Now we want to do the 11/16 drill. Okay, fine. Take our drill, clean these important surfaces, check our ram, and always use a rag or some kind of protective glove. Make sure you ring it in there pretty good, and we're good. We're going to come over to our part, prepare it for drilling, and in this particular one here, I would like to slow the speed down for this particular operation. It's a big drill. So I prefer to really go to 300 on our setting for RPM, our spindle speed, 300, and that's going to be B2. So we set B2, and we're in. So we have 300 RPM. I'm going to put a little cutting oil on the part, some on the drill, and we're going to drill this hole. The force and the pressure that you go in, you should be getting a chip similar to what you see. Good practice is, whatever hole you're going to drill, use the proper drill. Okay, we drilled through. Now we're going to bring it back, stop the machine, and we're going to remove this drill. Also, good practice would be to clean it. We're done with it, so we can just give it a quick wipe, put this thing back, put it away later. This is done. Our ream is coming up, but according to the print, we need to bore it. After you drill it, then it says to bore the hole to 735, 725. Okay. We have a boring bar, nice. I think it's got to be on center line also. You have radial clearance on a boring bar, which is for a hole, to bore a hole, which is to make the hole larger. And we're going to come in here, and I want to make sure we're on center line also. And by eye, it looks pretty good. They've all been set to center. Now, we need to open this up a little bit more, just to verify where we're at. Clean this a little bit. Let's take our caliper and just make sure we're zeroed, and it's on 0. And we're going to take it and just double check the hole. I like to put my index finger on the solid jaw, my thumb on the movable jaw, and just push it out. You let it go in and then float it, and you should be able to be there. And it looks to me like we're at 687 where the drill should be. That's exactly what they should cut, 687, we're good. We need to go from 687, well, let's just say 685 to 735 or 725, which is 40 thousandths. This cuts double, so you have to be careful. 20 thousandths is 40 thousandths on opening this hole. 40 and 85 is 25, so we should be good at 20, but I'm going to go a little at a time. Remember, you want to, let's bring the spindle speed back up again to C3, which is 5 1/4. It's good for boring. And we're going to do the long feed, and the long feed is D4. A, B, C, D. We're on D4. That's good. So our feed control for 3,000 feed rate on boring is good. I just like to make sure that I'm going in the right direction with my carriage. And let's We're going through this in and up, and we're going in, we're good. I come in with my boring bar. A good machinist, in order to tell if the boring bar goes through, you have to kind of like look, and you're going to get chips and stuff hitting you in the head. The best thing to do is to go through and look while it's stopped until it comes through. When you see it come through, then what you can do is take your Sharpie and put a little mark up here, so that when you stand back and you can see the boring bar going in, you can see this mark. So when you get to this mark, you know you're going to be through, rather than standing here and trying to see it, and it's very difficult. So we're going to come in. Generally, I touch off. When you touch, you know you're there. We said 20 thousandths would be max where you want to go. So I'm going to go 10, 15. That should be 30 thousandths. We're going to, let me just put a little cutting oil on this to help it out. Stop it. Good practice is light pressure on your tool post that way. It helps to not leave a withdrawal mark when you withdraw the tool. Now, I'm going to take my calipers. We went 30 and 85 should be about 115. Let's 715. Let's see where we're at here, just to check. We're at, looks like about 718. That's about right. And we want to go another 20 would be good, so there'd be 10 more on this. So I'm going to come back in, turn this on, and come out another 10. I'm going from 35, we're coming out, so the limit's going to be reduced. 25 should be perfect. Come over, put the in sheet on. Stop, a little pressure, we withdraw, and let's just check it out. We should be right where we want to be. They say 725, 735, we're at 737, and that's pretty good. That's fine. Okay, we're going to take this to 750 and 6/10, and we'll do that with the boring bar. So this tool is no longer needed. I'm going to put this down. And I also wanted to show you that we're creating this bore for this mandrel, okay? And a mandrel has a taper in the industry of 6 thousandths per foot, being as these are a half a foot, it's 3 thousandths difference between here and here.